Hello. Today we're going to be talking about some properties of similar triangles. So a couple of things that happen when you do particular things with these triangles, and you actually create some similar triangles here. So the first thing I'm going to talk about is if you draw a line that's parallel to one of the other sides, such that it intersects the sides of the triangle, it's going to intersect these sides proportionally. So that means that we're going to get a lot of proportions to use because it actually creates similar triangles plus a few other things for us. So let's go ahead and see this. I do want you to go ahead and put that this creates similar triangles, and so it gives us some things that we can work with. Now over here I have ID, and ID relates to IV the same way that DE would relate to EO. The top relates to the bottom the way the top relates to the bottom. Also, ID relates to DV, top versus whole, the way DE relates to DO, again, top versus whole. So this first one is part to part, and the second one is part to whole, and we're allowed to create both of those. So we have some examples over here that we're going to work out. This part right here was written incorrectly, so YL is the correct side length to put right there so that we can answer this. But let's go ahead and look at these. If I say AY relates to LA, that's going to relate the same way that YE, which is also the top, relates to this ER at the bottom. And now we say that AY, that would be this one, relates to YL, so that means it's this whole big section. AY relates to YL the same way that AE, which is the bottom of the small triangle, relates to LR, the bottom of the big triangle. So left side of the small to left side of the big, over bottom of the small, bottom of the big. Now if we go back with LY and we relate that to PL, so this again, top two triangles versus that bottom piece, that's going to relate somehow to RS, and it's going to relate again to those top three triangles, which is YR. PA, so PA, that would be this section right here, is going to relate to ES, this section over here, the way that AY, just the top left of the small, is going to relate to YE, the top right of the small. And so all of these statements are true, and it sets it up quite nicely for us. Now to actually use this in problems, we're going to set up these proportions and solve them. So I'm going to put 32 over 24. Well, 32 was on top, so I'm going to go ahead and put this 40 on top, and this is the side that I want to find out. Well, we just cross multiply and divide to get that x equals 30. And that's just 24 times 40 divided by 32. Alright, set this one up. We're going to set this up the same way. Again, I'm trying to figure out what x is. So 8 over 5 equals 10 over x. Again, I just cross multiply and divide. 10 times 5 divided by 8. And we get that x equals 6.25. But now this last problem, it is a bit different, because I have 5 and 8 And those are the small pieces, so I can actually go ahead and put 5 over 8. The 20 obviously relates to the 8, and we're very much tempted to put the x up here. However, this 8 is the whole of the bottom, the 20 is the whole of the bottom, 5, whole of the side. So if I need to put these two together and get x plus 5 over here to get that whole piece. And now we're going to cross multiply and figure out what this is. So 8 times x plus 5 equals, well, 5 times 20, 2, 4, 6, 8, 10 would be 100. 8x plus 40 equals 100. 8x equals 60. And if I take 60 and I divide by 8, I get that x equals 7.5. And so it's very important that when it's part to part, you set it up that way, but when it's part to whole, that you set it up as a part to whole problem. Now another trick that we have with similar triangles is if I do an angle bisector, then I'm going to create, again, two similar triangles. Alright, I'm going to create a similar triangle here and here. And these are also proportional. And so I can say 10 over x plus 2. And say that that is equal to 14 over 2x plus 1. And again, with proportions, we just cross multiply and begin solving. So 14 times x plus 2 equals 10 times 2x plus 1. So 14x plus 28 equals 20x plus 10. We can go ahead and subtract the 14x from both sides, as well as subtracting 10 from both sides, and we get that 18 equals 6x, which means that x equals 3. But they don't want x, they want RV, so we need to do 3 plus 2 and get 5 as our final answer. Now this problem over here, because of the decimals and the way it's set up, is a fairly nasty problem that leads not to a not so pretty answer. So we're going to go ahead and skip this, but feel free to do this if you want. The answer would be the ugly fraction 47 over 24 if you're interested in solving it. And this leads us to our last trick, which is very simple. It actually ties back into what we did first. And that is that if I have it set up on a coordinate plane like this, I can actually use it to find the coordinates of D. And I do that by knowing that this is length 2 from 0 to 2, and this is length 4. So 2 over 4 is going to equal, well, this piece right here is length 3. To find the whole piece, well, that would be the coordinate for D. Cross multiply and divide. 4 times 3 is 12, divided by 2 is 6. So D is located at 6, 0. Same thing over here. This is 6, but the whole thing is 15. This is 10, but the whole thing is, we don't know, 6 over 15 equals 10 over whatever C is. We can cross multiply and divide. 150 divided by 6 gives me 25. So C would be at 25, 0. And so those are 3 different things that we can do with similar triangles.